Okay, so here are my calculations that I did for the exam remediation. This is the P big A minus A little O2 or little a O2. So for that, we need to find the alveolar gas equation. So it's barometric pressure minus the pH2O, which is 47, multiplied by your FiO2, 0.95, minus your PaCO2, 55, multiplied by 1.25, or you could do divided by 0.8. So 713 minus 760 minus 47 equals 713, multiplied by 0.95 gets you 677.35. And here's all my math that I did for it. Yeah, so then once you have your alveolar gas equation, you could do the P big A minus little a, so 608.6 minus 80 gets you 528.6. And with that, it does show that there is an elevated gradient, showing that there is an impaired gas exchange, possibly could be VQ mismatch, or or just like or a form of oxygen impairment. And then for CaO2, it's your hemoglobin multiplied by the factor 1.34 multiplied by the blood saturation of 0.96 plus PaO2 80 multiplied by the factor 0.0031, and you get this long number. There's my work for it. Yes. And then 80 times that is 0.248, and you get 14,707, which is below the normal range. So it could indicate that the patient's hemoglobin is low, or the red blood cell count is inhibited by some sort of renal dysfunction. And then your shunt equation, QSQT. There was no CVO2 given to complete the equation. The anion gap. The anion gap is your sodium plus chloride or potassium minus chloride plus HCO3 bicarbonate. So 138 plus 5, 143, 106 plus 29 is 135, and then that equals 8. And that's within range. And then for the static compliance, that's tidal volume minus the plateau pressure and minus PEEP. And for the PEEP, we'll just use the assumed value of 5. And then to find the tidal volume, I did minute ventilation divided by respiratory rate, and it got me 0.65 liters or 650 milliliters, but I'll use liters. Divide that by the plateau minus 5, so equals 40. So the static is 0.01625. And that falls within the normal value range. The dynamic compliance, same thing, my tidal volume minus the peak inspiratory pressure minus PEEP, and it gets you 0.01083. This is slightly lower, so there is probably some indication of a decreased lung compliance and increased air resistance. And then for the air resistance, it's your PIP minus plateau divided by flow. And that's, we got, to find the flow, I did 65 divided by 60, and the answer I got was 18.46 centimeters of water per liter per second. And that's elevated, so that shows indication of airway obstruction. And then this is the time constant. It's your static multiplied by raw. And so it's 0.01625 multiplied by 1846, which is what we derived from the last resistance equation, and then the static equation. So it gets you 0.299, but round that up to 3 seconds. And then we have the inspiratory-expiratory ratio. And you get 0.58 per 1 on inspiratory-expiratory. And then the anatomical dead space is 1 ml per pound of ideal body weight. So the given kilogram was 60 kg. Multiply that by 2.2 to get 132 pounds ideal body weight, and then multiply that by 1 ml. So it is 132 milliliters per pound of body weight.